So I just want to demonstrate a bit just what is expected of you uh, for each of the tasks. So I'm not going to design the JK flip-flop. The lab say you should design the JK flip-flop. So let's say this is your design. Let's just say this is your design. Let's say this is your design. So let's say this is your design, taking the highest line to your LED, to your blinking LED, and then here you are taking 23 and 22, and here you're taking line number 22. So here you're taking line number 22 as an input to your clock to your JK. Yeah, but before we do this, let's say input. Let's say CPUK. Yeah, because right now you're trying to check hierarchy files. Yeah, so you can switch through the hierarchy. This shows you what will be executed when you press run. But if you want to see what's in your files, you can just go there. If you wanna go back to your other files, just double click on those. So once you've done this, since you have two files here, and on your hierarchy it's specified that you're going to be executing clock megahertz, which is this file here. Just right click on the one that you want to build and set as entry level. And then build. So that will build this one instead of that one we were working on the first time. Errors, okay, that's fine. Save that and build. So yeah, I was just taking chances, yeah. Apparently you can't paste this thing from another project to this one, because I was trying to copy that from the project that I made. That's fine. So after doing this, yeah, so you go to your new university program. Double click that just to select your outputs. Yeah, and then CPU, ignore this one because right now all we care about is the simulation. And then use 10, 15, 15 nanoseconds. Yeah. So here you have to demonstrate that your JK is working fine. So you'll be objective about it. What happens when J is 0 and your clock goes high, when your K is 1 and stuff like that. So you have to explain whether your JK is working fine. Something like this. This is what we expect as your result for the first part of your lab. And if you see that the simulation works fine, then you can continue. Then you remove this because you don't need it. You just need it for simulation. So you take Q22. You take Q22. It's gonna select the next line here, but the next line obviously is going to run faster than 23. Yep, so after doing that, you go to your pin planner, you select your CPU as H5, and then you have to select these, K, J, you should select these as your switches, you should select these as your switches, and your LED is it R1? Let's see. Your LED at R1 and R1 and P4. So R1 and P4. There we go. R1, and then this one's for Q. Just set your Q to P4. That's fine. And then here, you should also know where your P is going. I mean, where where JKs are going. So we said we're gonna set that to switches for now. You can either set them using the switches, external switches, but for now I think it's simpler if we use the onboard switches. So that's, let me see, that's R4 and M9. R4 and M9. Wow. So JK, R4, that's M9. Let's see, that's R3. How about? That is R3. That's R3 and M9, yeah. So close that. Let's see. Yeah, they save. So you close that. So as you can see, your pins are set. M9. Your Q is set to one of the LEDs, and your blinking LED is set, and your CPU is set. So your switches are active high. They are active low. When you press them, they go to ground. So by default, they are ones. So let's just put the NOT gates here. Let's put the NOT gates here. Just to just put the NOT gates here and build it. Yeah, and then you start programming. So as you can see, your Q is off and your LED is blinking. And then what happens when you press one LED? What happens when you press the other one? It goes on, it goes off. And what happens when you press the other one? So you have to be objective about your answers. You have to be objective about your answers, but yeah, but we'll see in the lab. For now, just make sure you know how they are configured. Make sure how you know that you know